Force of friction. Force of friction helps us to walk, to ride, to drive, or to stop the moving vehicles, etc. As the car runs, the pressure on the accelerator causes a force to act in the forward direction and friction acts in the backward direction. As the driver releases the accelerator, the forward force becomes zero. However, the car continues to move forward with a decreasing speed due to its inertia of motion. When the driver applies brakes to stop the car, he provides an additional force in the backward direction, which brings the car to a quick stop. The frictional force acts on the surface of contact of two bodies which are in relative motion, and its direction is opposite to the direction of motion. When we walk, we push the ground in the backward direction, as indicated by the red arrow. The ground exerts a reaction force in the forward direction, as indicated by the blue arrow. The vertical component of this reaction force balances the weight of the person and the horizontal component in the forward direction. That is, the frictional force which pushes us in the forward direction. Smooth and rough surfaces. The frictional force depends on intermediary surfaces. A smooth surface offers less friction, whereas a rough surface offers more friction. Here, we can see a penguin sliding on snow, which is a smooth surface that offers less friction. People use skating shoes to glide over the snow. In amusement parks, the slider surface is made slippery so as to reduce the friction. In order to increase the frictional force, the handles of cycle and treadmills are made of rubber to provide a better grip. A gymnast applies chalk powder on his hands to strengthen the grip, which otherwise reduces due to slight perspiration on the palms. The matchstick gets ignited on striking it with a specially prepared strip. This is again due to the frictional force between the two surfaces.